Hello everyone, Labs here. Today we're going to be making this map generation tool in the Godot game engine, version 3.2.3 stable. As you can see, I'm able to generate these maps, clean them up, and basically I get these large areas for fights and other small rooms and pathways, whatnot. So basically, of course you can generate this on the fly using code and loops and whatnot, but just to showcase this is how they're made. We have these cellular automata, as many people like to refer to them, just like individual creatures that do their own thing. But when you put their results together, they make a really clean and cohesive picture. And basically, we're going to be trying to make this in the Godot game engine. And let's get right into it. Okay, so for this tutorial, you will actually need a couple of sprites. You only need the black and white ones. You don't need the green and yellow ones. I was testing stuff out and I just needed 2 extra tiles. You only need the black and white ones. In fact, I'll just go delete the yellow and green ones to prove you don't need them. You just need a black and white tile. When I go to my default photo viewer app, you can see that it's just a black picture. Now onto the scene. We have 2 scenes over here. We have a tile map and a creature. A creature is just a node, and I just put a sprite on it so it would be easier to see. In our tile map, we're going to have to get a couple of variables, a width and a height, and we're going to make an enum, which is a fancy way of saying an array which has special numbers, which is basically a way of saying a bunch of constants which have special numbers. So because I got rid of the yellow and green one, I have to get rid of that. But so basically, an enum allows us to say tile dot something. So I'll just give a quick example. Tile dot, and you can see the code autocomplete shows up, black and white. If I actually go like this and I print it out, I'm gonna get a 0. And you can see I get a 0. If I do tile dot white, I get a 1. And it just basically tells you that the constant, or whatever you put over here, will be 0. Whatever you put here is going to be 1. Whatever you put here will be 2, and just to prove that. And you don't have to do them caps, by the way. It's just something a lot of people do, and it's usually the Godot standard, or like it's just common to make your enum all caps. But whatever. Let's actually get into making it. So I'm going to first have to explain the first principles approach we're going to take to making it. Let's say this is our scene, right? This is our camera scene. I don't mind those black pixels. Those are just for testing to see where the 1080p, or where if you extend the screen size, where would the maximum be? But where is the screen size? So right now, by default, when I click F5, it's going to be, of course, it's not defined. Basically, it's going to be this rectangle, and it's this purple rectangle. I'm not sure if it comes up on YouTube, but it's basically, it ends over here, starts over here, and that's what this red rectangle represents. What are we going to say? Well, we want to say something like, at the beginning of the scene, make sure the entire thing is black, and place these little creatures down, which will do our job. What do we want these little creatures to do? Well, I think it would be a really good idea if we ask the creatures to move it in choose a particular direction, and every frame or every loop move in that direction, but you also have a small chance of moving into another direction. Mainly, it's going to be in the direction they choose. Let's say this creature chooses the direction as left. So it's going to always choose left, and maybe sometimes it'll go up. And it'll move left again, maybe up again, maybe go down, maybe backwards, but mainly it's going to be moving in the left direction. And if we ask all these creatures that every time you take a step, make sure the tile behind you is white, not delete, make sure the tile behind you is white, you can see that we get this sort of maze-like or vein-like pattern where we can essentially just say that if they connect them all up, which this creature will especially do, or this creature, and when I keep saying creature, I mean this node over here. We're going to code it up so that it will actually be able to move. And just to give another example, you can skip this one. I'll leave a timestamp or whatever the YouTube table of contents is. Basically, we're going to be saying choose a random direction. So let's say this creature chooses its direction. It wants to be up, but it can also move left, right, or down. Remember that. But mainly it'll be moving up. So maybe it'll move up like this. Maybe it'll go like this, but mainly it's going to move up. And basically you can see that over time we're going to get this vein-like, but then also these blob-like areas and maybe more vein-like structures, and then we can create maps and rooms like that. So that's essentially the first principles approach. So let's try programming it. So what do we want to say in our tile map? Well, we want to make the background black, right? We want to obviously have the walls. Sorry about that flash. We want everything to be black, but I don't want to do that. I want to program that. So in my ready function, I'm just going to have 2 functions that say make everything black and place a creature. In my make everything black function, I'm just going to say for x and width, for y and height, set every cell to be black. This is stuff from the previous video. And then I'm also going to make a function called place creature. And essentially in place creature, although it looks a little bit scary. It's not. We're basically saying create a margin variable, create a screen size variable, and what we're going to be saying is place a random creature. You can see that if I actually remove this code, we're basically saying get a instantiation to a creature object, put its global position to a random x and y, which is part of the stuff I deleted, and then just add this, and then just add to the tilemap, which is the parent, just add a creature. And you can see that when I run the scene, I'm going to get 3 creatures. Of course, they're on top of each other. And if you really wanted to, you could add in a little bit of randomness. So, of course, you could do something like screen size .y -2 minus margin, and then over here on the after the comma 2, you could do plus margin. And of course, you could do that on the x as well. It doesn't matter, but there's multiple of them. And now that we have our creatures placed, we want to be able to move them. So how would we be able to move them? To move the creature, we should actually program everything related to creature movement in the creature node. The way I set it up was I basically said the creature will be assigned a type of mover, so a type of movement class. So either it will be a creature that likes to move down, left, right, up a lot. It will be assigned that, but it will also have a choice. So these are the other choices. So you could say moves, I guess. Moves are moves are rare, or let's just call it choices. So there will also be other choices, and the choices weight, so where it actually is in the array, will impact how likely it is to be chosen. So how can we set up a type of mover and set up this choices array? So to get our type of mover, we could basically say the type of mover is going to be equal to the mover type array, but we're going to be grabbing a specific spot, which is just going to be a random spot in it. So basically this statement that I highlighted, it basically says grab a random rand f, which is a random number from 0 to 1, multiply it by the mover type array size. So let's say it gets 0.3 times 4. If it gets something like 0.3, so this will return 0.3, and let's say this will be 4 because we can see it's this has 4 objects in it, or 4 strings in it. It will say 0.3 times 4. That will get us 1.2. This expression would evaluate to 1.2, but then floor would say, okay, let's get rid of the decimal and just say 1. So it will say mover type 1, and if we actually see what mover type 1 is, it's essentially right. So now that we have the type of mover, we can also say choices.append type of mover. Hopefully that makes sense because we're appending what we just assigned to. So it would be saying whatever we get from here. So let's say, continuing with the example, we got 0.3. This becomes right. We're basically saying choices.append right. Not that, but right. We're going to be appending right, and that will be our first choice. That will be the most likely choice. And then over here we have a loop that says for the type in mover types, if the type is not equal to us, so if the type that we're looping over is not equal to us, we're going to append it afterward. If that part didn't make sense, please leave a comment and I'll try my best to explain it. But this is the hardest part. Like, this was the actual hardest part of the entire tutorial / project, and the rest of it is pretty easy. So afterwards, I'm just going to declare a couple more variables. I want to get reference to, I'm just getting a couple more variables in, a map, which is essentially our parent, because we're going to add the creature as a child, right? We said add child creature. So if we look at from the creature's perspective, the parent of the creature is the map. So we would want to get reference to the map. And we're basically going to be saying wherever we spawn, just set that tile to white, which is 1. So how are we actually going to be moving this creature? Well, we could say something like in the input function. So we could actually test it out. We could make some actions that relate to moving once versus moving a lot. And the only difference you can see is that instead, the only difference between move and move a lot is that we're looping over it 30 times, which means we're basically calling this function 30 times. Whereas in move once, we're just calling it once. And you might be wondering what is move a lot and move a lot. Well, if you go to our project settings, input map, I type in move, you can see I've already defined a action, which is just so moving once is a space, and moving a lot, where is it? Is just the letter X. These are just random things I made up. You could do whatever you want. We also have R, which is for restart, C for cleaning. We will use those ones later. And now we're going to talk about our move creature function. So remember I was talking about how we have to have a type of mover. Well, this is where it's going to show up. So you can see I actually just copy pasted these two functions. So we have move creature, and in move creature, we're basically getting a random float from 0 to 1, and we're basically biasing the first choice. So because random float, randf function can return anywhere from 0 to 1, if we say it's less than 0.5, we'll pick the first choice. So let me just go to paint and draw out what that means. So let's say this is our probability bar, and from 0 to 1. Okay, so 50% means somewhere over here. Whatever this is going to be the 0th index. If we do something like less than 0.67, less than 0.67 is like somewhere over here-ish. And then 0.75, 0.75 is like here-ish. And then all else. Of course, this is like, I didn't draw it to scale. Like, it would be more like this, because now what we're basically having is we're going to have the system where we choose this one, second, third, let me just do that. And third, we're basically choosing the 0th one 50% of the time. Maybe the first choice, like 16% of the time, second choice 16% of the time, third choice 16% of the time. But mainly we'll be choosing this first choice. And this correlates to moving in one direction a lot. And these other ones actually correlate to moving a little bit away from it. So you can see up here, we were able, like, we moved left when this creature's main goal was to move up. That's basically how we're doing it. We're basically making this probability density, and we're basically trying to say, oh, okay, mainly you're going to be moving left, right? Because this is the most likely possibility. But sometimes you can also move right. And that's basically a simple way you could set that up. And what's determined move? Like, there's this determined move function and we're passing in something. Well, we're basically going to be passing in the string. And I know it's kind of a primitive way to do it, like passing in a string to determine what you're doing. It's kind of a bad way to do it, but it's actually not bad for this situation, just because we actually know all of the possible outcomes that can ever happen. And unless you make a spelling mistake in your code, there shouldn't be an issue. And the reason I keep scrolling up is because I actually want to copy this so we know what we're dealing with. And these are the strings that we will be working with. So I'm actually going to pull out some fancy GDScript, and we're actually going to be using the match function. So before I explain that fancy GDScript, there's just this tile size variable. So this tile size variable, tile size. This tile size variable will be whatever your tile size is. So mine is 8. That's my naming convention. I type in the color of the image, and then how many pixels is it? 8. But that's actually not what I wanted to grab. I wanted to grab the tile size, which is also 8. Silly me. So just make this 8. Yeah. So that's 8. And basically the way we're moving this creature is by literally just saying global position plus equals a vector 2. And depending on what the input is, so depending on whatever this determined move function gets, we will be moving the creature in a different way. For example, so match function is basically a bunch of if else. So this is no different than saying, this block of code is no different than saying it like this. But the reason I chose to do it like this is to show people a really cool way of doing it. But imagine if we had 8 directions, or maybe 27 directions if you're doing a 3D map. That would be really hard to do a bunch of if-else statements. But a match function makes it a lot easier because we already know what we're comparing. We just want to compare it and get it. So this what block I just highlighted is functionally equivalent to this one. There's no difference. And in fact, I will comment this one out and we will try it with both of them. Not line number, but we'll try it out with both of them and see that there's actually no difference. So that's how we're going to be moving our creature. So with all that being set up, we can just go make our scene and we can click X to move. But you can see that we are getting the creatures to move. Like they are moving. I'm not sure if they're showing up because of how transparent they are, which I easily did through the modulate. And the reason it was an error is because it can't really get its own self as a parent. We actually always have to run the tile map scene, and you can see we're moving around. Like there's nothing wrong with the creatures moving. They're just not placing anything. So I think it would be a good idea in the move creature function if in the move creature function we said something like map.setCell. We're going to set the cells to a certain position. Don't mind this. We're going to set us to white. But what is a certain position? Well, we can just make a couple of variables here to make it easier for ourselves. So what are we going to be setting these positions to? Well, I think it would be a good idea to set it to the map position. So what's the map position? So the map position is actually, if I go over here to my tile map, if I go over here to my tile map, in the bottom left corner, I'm not sure why I'm zooming in, it doesn't make this bigger, but in the bottom left corner, this is the tile map position. So like right here, this block's position is 1253. But in Godot, that block's position might be something like, I don't know, anywhere from whatever the distance is from here to here. So I can actually measure that. So in Godot, that tile, this block over here, this position's around like 100 by like, what was it? 424. So this position does not correlate with the tile map's position. So we actually have to use a special function saying So we actually have to use a special function saying map.world to map, taking our world's position, which is our global position, and we're converting it to a map. And the reason we have to get.x is because we have to plug it in as x and y. And now that when we run the scene, you can see that we get our, basically we get these creatures to make, they're mainly going along their path. So I can assume this one's path was to move downwards, but you can see it's also moving to the right a bit. And sometimes it moved up and sometimes it moved left. But if we restart the scene, we get different sets of paths and stuff. And they're actually not making the tile white. Now, why is this the case? The reason why it's not working is because I actually deleted those 2 tiles from the beginning, at the beginning of the video, and it turns out that actually stuck. And the way you can easily fix that, if you ran into the same problem like I did, you can actually just delete your tile. Hello? I want to delete my tile. Oh, I have to click region and then delete. So you can just create a new tile. That will solve the issue. And there's no collision shape on the white tile, and you can see it's fixed. Now, when I rerun the scene, same code, everything, you can see that I get my paths. But I want something a little bit more interesting. I want it to be, I want these creatures to spawn a new creature. Also, after a random chance, they have to die because we can't keep the same creatures for too long, or else we'll just get a really long path that goes on in that direction. Of course, it'll look like this, but still, we don't want that path to continue on. We want like branches to diverge and like. For example, this creature continued to live on forever, but in this other example, this creature died, but it spawned a new one, which maybe went up, and then it died and spawned a new creature that maybe went to the right, but something like that. And we can basically achieve that by understanding that the random f function gets a number between 0 and 1. Like, that's all it does, and it's really powerful because if it's less than 0.02, which is a really small chance, right? If something's between 0 and 1 and it's returning stuff like 0.3, 0.002, 0.9, like it returns a random number from 0 to 1. If we say less than 0.02, get parent, make a copy, and set it a pass in a global position, we're basically saying make a copy. But now you might be wondering, what's get parent.make copy? Is that a function in Godot? No, that's something we can make, and then a smaller random chance, or essentially like getting rid of it. So we can actually make a function in our get parent which makes a copy. So we're basically saying like make copy is we're passing in a certain position, and we're basically saying get a creature, set the creature's global position equal to the position we passed in. These are the exact same variable. You can see I can type this and this, and everything will run smoothly. And you can see that over time we get more creatures, and they're all making their own pathways, and that's pretty cool. But and we're basically done. This is the entire tutorial. Like, that's about it. But if we want to like make a couple more clean, like we want to clean a couple things up, or we can basically make a couple of things where we say if the input.action pressed is R. Remember, we went to our project settings and defined a couple more things like R and clean and purge. Like, we defined a couple of them. So R will just restart the scene, P will just get rid of all the children regardless of who they are or what they are. We'll just get rid of them so we can actually see the map, and clean will clean up the map, which we will implement very soon. So right now you can see that if I just click X a lot or spacebar is actually one step, and you can see what I was talking about of going, like, mainly this one wants to go left, I'm assuming, but it's also moving, or maybe up, I'm not sure, but it's moving in its own way, and they're like kind of like worms or ants or whatever. But this is essentially cellular automata, and if I click P, all of them are gone, and we're left with our map. And we can also make the clean map function. The clean map function is a little bit complicated in my opinion, but it's only complicated by how it looks. So in our clean map function, we're basically going to be looping over the entire thing. So this is okay. We're basically going to be looping over the entire map, and we're going to be saying if the cell that we're getting, like if we're looking at a black cell, so let's say we have a bunch of tiles over here, and there's a couple of white ones. So it's basically going to be looping over the entire map row by row, and let's say it encounters a black tile, right? So let's say it's just looping, or it would actually be better if I made a lot of them white and then a couple of them black. So it would be looping white, 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 white. Oh, and then it sees a black one. It will go to this black one and ask, is the cell to the left top of you white? Else return a 0. If is the one directly above you white, then add 1. Else don't add anything. And this is just a one-line if statement. It's called a ternary operator. They're really helpful for stuff like this. And this is kind of repetitive, I will admit, but it's the only way we could really check for cells near us. So let's say this is the one cell. We're basically asking, are you white? 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 We're not doing it in that order. We're doing it in this order. We have to ignore ourselves because we don't want to include ourselves in the calculation, right? That wouldn't make much sense. And after we do that, we're going to say, are there more than 6 white cells near you? Are there more than or equal to 6 white cells? If they are, just set them to white. And what that basically does is it allows us to go like this, and it says C for clean. It basically gets rid of all those like 1 tiles, because let's say we have something like this. Yeah, this is a perfect example. Let's say we have something like this. We actually have 1, 2, 3, 4, 5, 6, 7, 8 white tiles, and this kind of white 1 pixel, like black pixel in the middle of our entire game. Let's say our entire, like, this is like an open scene or something. This 1 black pixel is really bothersome. Like, it shouldn't be there. So we can just get rid of it essentially like that. But let's say we're over here and we encounter a black pixel over here. Well, we're basically saying so there's only 3 white pixels near you. It doesn't make sense to get rid of you. And of course you can play around with this value. Like, let's say I have something like this and I let them run for a lot. Then I click P to clean this up, and then I click C. You can see it does get rid of a lot more, and it's actually a lot smoother. In fact, I like that actually. Wow, that was actually a lot better. So you can see it gets rid of a lot of stuff, whereas in the other one we weren't getting rid of all that stuff. Like, I would actually prefer to have that black thing in the middle, but if you do a smaller number, it won't keep it. So that's just something to keep in mind. So like over here, when I run it, see this thing over here wasn't going to get deleted, nor were these things, and I think that gives the map a little bit more personality, but that's just my opinion. But yeah, that's how we can clean up the map a bit. I am actually going to get rid of all of these. So I actually removed the older set, and you can basically make this large giant statement, and essentially what it does exactly what we saw before, which was this. But instead, I kind of like it to have it like, it helps me understand where all my code is, at least for me, because I can see over here in the top right that there's these giant lines, and I know this is where the actual stuff is happening, or the lines of code that regulate where the cells are placed. And you can see that we actually have x, x plus 1, x minus 1, x. We have y, 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 and we have y plus 1. This basically allows us to have larger, thicker veins. So if I comment these out, you can see that we're actually getting tiny veins, and there's nothing wrong with that, but I would actually prefer if they were more like this. This is a really cool feature I learned in Godot. If you save the script in the middle of the thing, it'll actually change and start working with it. So that's really cool, and you can basically get something like that. And I think that's it to this tutorial. There's nothing else. Oh yeah, wow, I can't imagine I scrolled to the right part. So we're going to try it with this, and you can see it gets the exact same thing. Like, the exact same thing happened. I'm not sure why they died off. That was just a really unlucky chance. Like, that was a really, really small event really, really small chance of happening. But basically, we can get these maps, and of course, they're infinitely generated, and we get these really interesting patterns. And that's really all I have to say for this tutorial. If you liked it, that's amazing, and have an amazing day. And when I go over here to the white one, same thing. It's just a white pixel. I have no clue how I went to the yellow one, green one though. It's just a white pixel. Like, there's nothing to it. So let's say, oops. So oh, okay. That's where the error is.